All right, let's get right into it. For the last 10 years, we've all been sold one simple story about artificial intelligence. Bigger is always better. But what if that whole story, the one driving this multi-trillion-dollar arms race, is just plain wrong? We're going to dive into this because something huge is happening right now, a total inversion of everything we thought we knew.
This quote? This is the whole ball game. It's a direct shot at the bigger is better philosophy that has shaped AI for a decade. It's saying that real smarts, well, it's not about lighting up the whole brain at once. It's about knowing exactly which neuron to fire and when.
You have to understand, for years, the entire industry has been running on this one super powerful idea, that if you just scale things up enough, intelligence will just, emerge.
But now, that core belief is getting flipped completely on its head. The very ideas that built the AI giants we see today are being challenged, and a whole new way of thinking is starting to take over.
So, to really get this inversion, we first have to appreciate the era we are now leaving behind. Let's call it the age of brute force. This is the story of how we got so obsessed with building these absolutely enormous digital minds. And this, right here, is the heart of it all. The brute force principle. It's this simple, almost seductive idea that if you want a smarter AI, you just have to make it bigger, more. For years, this was the playbook for literally everyone in the game.
And the recipe for making it bigger? It was almost laughably simple. You just throw more of everything at the problem. More GPUs for more horsepower, more data to learn from, more parameters to build a bigger neural network, and more tokens to process. This exact formula is what took us from models with millions of parameters to models with trillions.
But this quote just nails the fundamental problem with that approach. These giant AIs are just wildly inefficient. To answer one simple question, the entire massive network has to light up and go to work. It really is like turning on every single light in an entire city just to read a book in one little room. And that waste, well, it has a massive hidden cost.
And this is the Great Inversion. The real crisis in AI today isn't what we all hear about, the cost of building these massive models. No, the real problem is the absolutely staggering cost of just running them day in and day out.
I love this slide because it just reframes the whole AI economy. We all see the training part, right? It's the big show, the spectacle. It's like the moment you finish building a massive, beautiful cathedral. But the real, soul-crushing cost is what comes after. Inference. That's the daily metabolism. It's the bill you have to pay to heat that cathedral forever.
And this is what we're calling the inference crisis. The real bottleneck holding everything back isn't a lack of computing power. It's the cost of memory movement. Think of it like a terrible logistics problem. Every single time the AI thinks, it has to shuffle these enormous chunks of data around, and that process is slow, it's expensive, and it's the real monster hiding in the AI budget.
And our hardware is a huge part of the problem. This analogy just hits it perfectly. We designed all these incredible computer chips for one specific race, training. It's a drag race, one massive parallel sprint to the finish line. But inference, the day-to-day use, is a totally different job. It's more like a city bus route. Lots of starting and stopping, little requests, super sensitive to delays. We are using the wrong tool for the job.
Okay, so if brute force is just too expensive and clumsy, what's the alternative? Well, it means we have to completely rethink how we build these things, the very architecture of intelligence. We have to move from raw power to smart, elegant design.
Which, of course, brings us to the billion-dollar question. If just making it bigger isn't the answer anymore, then what is? How do we build an AI that's not just powerful, but also practical and, affordable to run?
And the answer is actually inspired by nature, by our own brains. You don't build one single monolithic superbrain. You build a cognitive team, a council of specialists, where each part has a very specific job, and it only wakes up when it's actually needed.
And here's a real-world example of what that looks like, the Echo architecture. So check this out. A tiny little module called the Sentinel acts as a gatekeeper. It first looks at your question and decides, how hard is this? If it's simple, it just passes it to the main Atlas language engine. But if it's hard, it calls in the specialist from the guild, an expert in math or one for coding. The archive acts like an open book library for facts, which cuts down on hallucinations. Then, the oracle plans out the answer before it's written, and finally, a verifier checks its own work for errors. It's a team effort, and it saves a mind-boggling amount of energy. Now, this whole shift away from brute force, it's not just some technical tweak. Oh no, it is completely changing the business of cloud computing. The whole nature of what it means to be powerful in the tech world is changing. And the grand prize? It's not what you think it is. See, the old cloud war was simple. It was a fight over who owned the most hardware, the most raw computing power. It was about owning the factory floor. The new war, it's so much more subtle. It's a fight to own the interpretive layer, the smart dashboard that can see and manage the complexity of all the factories all at once. This is a new kind of power, and it's called empire by middleware. This is where the real control doesn't come from owning the physical stuff anymore. It comes from owning the essential piece of software that sits in the middle and makes sense of all the chaos. Think about Google buying Wiz, a company that does nothing but give you a clear view across all the different clouds. They didn't buy a factory, they bought the map to the entire kingdom.
And that's really the key takeaway here. In a world that is drowning in complexity, real power is flowing to whoever can provide clarity. The most valuable real estate isn't at the bottom of the stack with the servers anymore, it's in the middle, with the software that makes our crazy digital world, well, understandable.
And this leads us to the final and frankly most mind-bending part of this whole story. What happens when these efficient, specialized AIs are no longer just separate tools, but they're all connected into a global network? What happens when that network reaches a certain density?
In science, there's this incredible concept called critical density. It's that magic tipping point where a bunch of individual, separate parts, whether they're neurons or ants in a colony or AIs on a network, suddenly stop acting like individuals and start behaving like a single, coordinated system. It's a phase transition, like water turning to ice.
So once our global AI network hits this critical point, we could be looking at a few wild futures. Best case, a cognitive renaissance, where AI just massively amplifies human genius. Or we could get algorithmic instability, where these feedback loops spiral out of control and create chaos. We might see a future of true human-AI symbiosis, or we could witness the birth of an emergent supersystem, where the network itself effectively becomes a new kind of intelligence. And that leaves us with one final, and honestly pretty haunting question. You see, emergent systems, they don't usually send out a birth announcement. A single neuron doesn't know it's part of a conscious mind. So if this planetary scale network of AIs begins to act like a single thinking system, how on earth would we even know? Because in the end, that's what this great inversion is all about. It teaches us that the next chapter of AI isn't about the grand spectacle of building one ever bigger brain in a box. It's about the much harder, much more profound challenge of wiring that intelligence into the very fabric of our world. Thanks for tuning in.